Awesome. And we are live from Amsterdam, Berlin, and all the way from Tucson, Arizona. Welcome to a KubeCon special edition of the HashiCorp Terraform Community Office Hours. I'm your host, Kerim Satiril, and we are joined today by Alex Somesan and Phil Sauter. But before we jump into introductions, a quick word on our code of conduct. Please keep in mind both the KubeCon and our code of conduct, very important. In general, let me actually switch this over because that's going to be a lot more easy for everyone to follow along. Be welcoming, inclusive, friendly, and patient. I know I'm reading this out, but the thing is, it is something that is important to us. It is important for you, and it is important for our community. So be welcoming, inclusive, friendly, and patient, considerate, be respectful, and be professional. In essence, don't do anything that you might regret tomorrow because this is a small community and we all like each other. We'll have a link for the full code of conduct in the chat as well. But with that, let's get started. We'll start with you, Alex, because you're here for the first time. What do you do at HashiCorp?
So I'm your average software engineer at HashiCorp. I work on the Kubernetes support for Terraform team, if you want to call it like that. Internally, we call it strategic providers. So what we do there is we maintain the Kubernetes provider you all might have already used, I guess. We also maintain the Helm provider. And more recently, we introduced a shiny new one that is supposed to cover the entire Kubernetes API in a more generic fashion. And that's what we're going to be talking about later on today.
I like shiny and new. Thank you. Phil, thank you for being back 5 times now. I love it.
Oh, thank you,
So
Kerim.
what have you been up to lately?
Oh, yeah, lots of stuff. We've got a lot going on the Kubernetes ecosystem team, strategic providers, as Alex just said. And so just by way of introduction, for anybody that hasn't seen me on one of these before, I'm Phil Sauter. I'm product manager. I'm the product manager working with the engineering team on the Kubernetes ecosystem, which includes all the things that Alex just mentioned, plus the Terraform Cloud Operator for Kubernetes, which is a really cool other non-provider project that we have that integrates the Terraform, or I'm sorry, the Kubernetes control plane with Terraform Cloud, so you can control Terraform Cloud directly within Kubernetes. And so I'm excited to talk about that a little later as well.
Yeah, I think we've got quite a packed program. So, Alex, do you want to start with showing us some cool new stuff?
Yeah, definitely. So I'm going to start sharing my screen here. I hope everybody can.
And in the meantime, if you have questions about anything you see on screen, feel free to drop them in the chat. We'll answer them as they come in and as it makes sense for us to answer them.
Yeah, by all means.
It's going to be fun.
So, as I mentioned, we recently released this new Kubernetes provider that we, for better or worse, now call Kubernetes Alpha. That is not a permanent name, but as everybody knows, naming is the hardest part of software engineering. So we're actually open for suggestions if you have opinions about that. Anyway, it's a new Kubernetes provider that was built outside the regular SDK that all other providers for Terraform use so far. And we've done that so that we can implement a very long asked for feature, which is support for custom resources and custom resource definitions. Coincidentally, the provider covers the entire API, so you basically can use it to manage Kubernetes generically, but the emphasis is on having good support for custom resources and custom resource definitions. And so I'm gonna start demoing something really small here. I've picked ArgoCD as an example for today's demo, just because it has a very clean set of manifests for installation. So looking at the ArgoCD website, there is simply a kubectl apply command that they invite you to use to actually install Argo, and everything needed to install it is in this YAML manifest here, which is quite substantial. But we are going to install with Terraform today. And so I'm just showing this for comparison. This is a set of resources, quite an extensive one, that deploys Argo. With the new provider that we've been working on, you can simply convert vanilla Kubernetes manifests to Terraform manifests, to Terraform configuration, HCL. Colleague of mine has built a very nice tool for that, which is called TF-K8s. You can find it. I'm going to quickly show the repository here. You can find it in GitHub at jrhouston/TF-K8s. So John is a member of our team. He built this thing to support the provider. And what the tool does is basically it takes YAML and produces TF. It's as simple as that. And to use, I've already run the Argo YAML through this tool for simplicity. And we have an installed TF file here, which we can have a look at real quick. And this is your familiar Terraform syntax, HCL resources that actually map one-to-one to the YAML resource description that everybody's used to. And so this is really easy to transition to. Let's just install Argo right now, and it's as easy as doing an init here. I forgot to mention, I have a Minikube cluster running. So we're gonna run this locally right now. And so I've initialized here Terraform as you do, and then it's as simply as just doing Terraform apply. And then this will deploy Argo with their officially published Kubernetes manifest translated verbatim into Terraform HCL. This is going to take a while because it's Minikube and it has to pull container images and whatnot. And so in the meantime, I actually want to go over what we're going to do next. So once we've installed Argo, we have one of the options of interacting with Argo among a UI and a CLI tool is using custom resource definition, custom resources essentially. And so Argo publishes a type called application. So if you go into the Argo manual and declarative setup here, you will see they explain how to create or how to deploy applications via Argo by describing them in a custom resource definition. And we're going to be using this exact bit of text here, which is their example application. We are going to literally just take this and transform it in HCL. This is what it looks like in HCL, but let's just not trust that. Let's delete it and recreate that manifest. I'm going to show you how.
Because we know demos always smoke and mirror, right? How do I know this is actually what comes out there?
So there is obviously no, there is some leftover state here, which we need to get rid of. We don't want to be cheating, right? So we have a pristine folder here. I'm just going to use the TF-K8s tool that I was talking about. We need to tell it that it's going to be used for the Kubernetes Alpha provider. This actually inserts the provider relationship in the resource that is needed to run the Kubernetes Alpha provider. So I'm just going to type here Kubernetes Alpha, which is the name of the provider in the registry. And then that is it. We're just going to pass it YAML literally on the command line like this. And what you get here instead is HCL. So we take this and we put it in the we put it in a new file called app.tf, but not in the install folder. Outside of it.
So while you insert this, you mentioned that you're using this on Minikube. I'm currently running an AKS cluster, so managed cube on Azure. Would this work there as well?
Of course, it really makes no difference which cluster you're targeting. It's still Kubernetes. It's the standard Kubernetes API that we've built against, so it works just as fine. Even more so, GKE now has some mechanisms in place where they use custom resource definitions to control some aspects of the cluster. So for example, Config Connect is one of the features that GKE offers that's accessible via custom resource definitions. This used to not be possible to manage by Terraform, but now you can actually do that. And so, as you might have noticed, this installed 35 resources. They're all of type Kubernetes manifest. So this tells you it's been using the Kubernetes Alpha provider. We can go ahead and actually, well, there's one more step that we need to do here is Argo publishes the login credentials in a secret. We need to extract that. I'm just going to use kubectl for that. And then we need to port forward the Argo UI so we can actually have a nice look at it. And this actually allows me to open the Argo UI locally. I'm going to take the password off of here. Don't copy that because it's just running on my local machine. So you're not going to be able to hack me. So if I just go to localhost in the port that I just forwarded and type my login credentials in here, we have an Argo instance running locally in Minikube. And so now we want to actually create a workload in Argo. And it is as easy as applying this configuration here. Well, one thing we need to do is change the namespace because we've deployed Argo in the default namespace in Minikube. So I've changed the namespace here. This is all you need to do to create a custom resource. As you may notice, this actually is a custom resource kind. We should check that the resource is available in the cluster first. So if we do this, our cluster contains obviously the two types of CRDs that Argo defines. And we're just gonna now be able to apply this. If we initialize first.
See, in that error, that tells you that this is a live demo rather than something pre-scripted.
Nothing has been prepared in advance. And so now if you go to the Argo UI over here, there's a guestbook application that has been created. And so that was solely done via Terraform. We haven't touched Argo CLI. We haven't clicked anything in the UI. If we now consult the applications type via kubectl, for example, we will see there's a guestbook custom resource that has been created via Terraform. And so that's it. That's the big news. Terraform can now actually manage custom resources and custom resource definitions. And it all shows up really nicely in state. So if you have a look at the Terraform state that has been produced, you actually see all of the attributes as regular Terraform attributes in the state. So you can use interpolation references and all the usual mechanisms that you're accustomed to with Terraform to create relationships between resources, pull data off of one resource into another, all the nice good stuff. Yeah.
If I want to use functions or put in my own certificates through the certificates manager or whatever else, it just works that way.
There you go. Yeah, you can actually extract data off of the resources once they've been created, put them in outputs, reuse them in other modules, all the usual things you're used to with Terraform.
Awesome. I'm curious. Alpha makes it sound like maybe I shouldn't be using that in production. Phil, any thoughts on this? When is it ready? technical troubles there. All good. We'll come back to that question later. In the meantime, we saw a question from Mohammed in the chat. This one is a super good question on adding capability to extend plugins outside of providers, and that's definitely something we're thinking about. We have community office hours for the Terraform SDK every so often. At that point, that question might actually be answered way better, unless you happen to have an answer for that.
So I'm not entirely sure. I'm gonna have a look at the question myself. I'm not entirely sure what.
This one isn't in there.
Okay.
Sadly.
Providers are plugins. So the way Terraform interacts with providers is providers run as a standalone process, and Terraform makes calls into them. So they can be developed independently. They're standalone binaries. They have their own development cycle. I'm not sure what kind of plugins are you thinking about when you say plugins for CLI. So if we had more data there, we might actually be able to offer some guidance. But in general, as long as you follow the Terraform provider API, you pretty much can build anything as a plugin.
Awesome. So there's your first answer, Mohammed. We'll happily dive more into this in the SDK office hours, because that's where people are that have an even more extensive answer. Welcome back, Phil. Glad we got to resolve the technical issues there. So question for you. The Kubernetes Alpha provider. Alpha is a tricky word, right? I mean, if you take popular email services, they've been in beta for like a decade, you know. At what point should I be using this provider?
Yeah, great question, Kerim. And apologies for the earlier inconvenience there. Yeah, so Alpha provider right now is, as its name suggests, in an alpha state. And so we do not suggest that you use this in production, although we would love for you to use it in your non-production environments and send us your feedback on what works and what doesn't work for you and your use case, and how we could potentially extend it. That said, we are working towards, making this a production-ready, rock-solid provider that you can count on, for all your Kubernetes needs. And we're getting much closer to that. And I can, without, giving you a specific date, I will say that we are progressing quite nicely towards a beta release. And at some point in the near future, we'll be ready to publish that.
That is exciting. So one thing that Alex showed us was that you added the provider name in there to make sure you're targeting the alpha provider. Can I use both providers at the same time without conflicting?
Yes, you can. But the reason why I added the provider name explicitly in the manifest resource is because although the provider is now called Kubernetes Alpha, the resource name is Kubernetes_manifest. And so that belongs to the Kubernetes namespace, which is currently occupied by the main provider. And so without that provider reference, the Terraform would try to pass the manifest resource to the main Kubernetes provider. We are trying to find a better name for it. And once we've done that, the resource name will follow that as well. And we won't need to reference the providers explicitly, but they can easily coexist. You can pass in data via expressions from one to the other. You can, for example, create the namespace with the main provider and then create a deployment in it via the alpha provider or the other way around.
Yeah, I'll just add on to that. Not only can you do this, use the providers in combination, but that is roughly the way we expect users to use the provider, right? The user experience between the two providers is very different, and the alpha provider, right, is much more verbose, but it's also a much closer match, or it's really an exact match to what you would expect in Kubernetes manifest YAML. But a lot of people really like the streamlined UX of the original Kubernetes provider, and so for those things, the standard resources, namespaces, config maps, secrets, etc. You may like the UX better of the Kubernetes provider and use the alpha provider as a breakout for anything custom that you need. And I think that's a great way to use the two providers together.
That is actually how I've been using them, mostly because, if there's a Terraform resource for something that I can use without, massaging YAML, then I'm always happy. We had a question from Mohammed asking, what is the upgrade/update story for custom resources?
It is exactly the same as you would do without Terraform. So custom resource definitions API version 1 requires everyone to define versions explicitly, and also migrations between them. So migrations, as far as I know, usually are implemented with webhooks on the API. There's nothing in Terraform that needs to be specifically adjusted for that. It'll just work the same way as you would upgrade a custom resource definition via kubectl, for example, from one version to another, if that is the point of the question.
Yeah, and something that I'll just add there as well, Alex, is especially if you're coming from Helm, right? You may be used to certain limitations, especially around the full lifecycle management of custom resource definitions, right? Helm does not allow you, unless things have changed since the last time I looked, does not allow you to delete custom resource definitions through Helm. You have to do it externally. Terraform does not impose this limitation. So if you apply a custom resource definition, you have full lifecycle management of it, including deleting that custom resource definition. So we took this, we approached this way, intentionally, but it does, I guess with great power comes great responsibility, right? And so you need to be aware that if you are applying custom resource definitions, you can also remove them. And if you've applied custom resources against that custom resource definition and then delete the definition unintentionally, you could suffer some data loss through that mechanism.
Yeah, definitely. And I would add to that the provider actually uses a patch mechanism, a patch API operation to update the custom resources, not just the custom resources, any resources it manages. And so it correctly updates in place rather than removing and recreating, which is basically being friendly to operators, which might be sensitive or might only be watching for updates or might be having different reactions to create, delete, and update events. And so the Terraform provider does make sure that whenever you make an update to the resource, it always does a patch and not a replace of the resource. So your operators will play nicely with that.
That is a very useful feature. I almost thought it was a joke when it was released in the Helm provided the diff support, which came out on April 1st, if I'm not entirely mistaken. I was like, is that a joke? But it definitely is not. Storing rendered manifest, it's a nice way to make Helm diffs more useful. Yeah. I like stuff that doesn't go away and services that don't have, a permanent outage.
So users have been for a very long time complaining that there's very little visibility into the underpinnings of a Helm chart, especially when you wrap that around with Terraform. You have Terraform and then you have Helm underneath, and then you have the Helm chart doing things. And so it was very difficult to actually get feedback from in real time from the chart being applied. We've now added a mechanism where the plan operation in Terraform will actually render the chart for you in the plan output, and you'll be able to see exactly what changes are being done to what resources before you apply. So that's quite useful, especially given the fact that you can't really observe what's going on with Helm in real time.
In general, anytime you start working with more than a handful of demo resources, it gets a lot harder to see what you're actually doing. Personally, I'm a huge fan of the concise diff and just seeing the few things that I changed after the first iteration. In the meantime, we got another question from Mohammed asking or suggesting it would be very nice to add a way to run unit and integration tests right from Terraform. And if you haven't upgraded to 0.15 yet, there is some cool new stuff in there. This is among one of the things. We've shipped an experimental module testing framework under Terraform space test. So spacebar, not the word space. Can definitely give that one a try. Please note that it's experimental. When you run it, we've got a link in there on where you can provide feedback. We want that feedback. We definitely want to hear how it's working for you, what's not working, what you expect it to do, and what it may or may not have done. I think that's always nice. And good on you for thinking about adding tests to your Terraform code. Because a lot of times when you think about IAC, we codify everything, right? We version it and everything, but we don't actually do anything in terms of testing other than waiting for Terraform apply to finish with exit code 0. And it's like, yeah, cool, my resource is here. But does it do what I need it to do? So definitely a feature worth checking out. And you two, have you, Phil, I know you write a lot of modules. We should talk about that for a little bit. I think you wrote the KubeConfig module like a couple weeks ago by now. Time flies.
It does fly. Yeah, it was really recently that I wrote this kubeconfig module. And so, one of the things that I hear constantly in the community is I need to generate a kubeconfig, and how do I do this via Terraform? And people seem to be sort of reinventing this wheel over and over again. But that's not something I like to see, because I want people to be able to focus on things that are productive and new, and not sort of the table stakes of like, how do I generate a kubeconfig, right? That should just kind of happen for you. And in many instances and in many modules out there, it does happen for you, because people, like I said, have solved this over and over. But what I wanted to do was to provide a module that just solved this specific use case, so that, if you're writing a module either for internal consumption or for the community at large, right, you don't have to figure out how do I construct or reconstruct a kubeconfig and then send it to a file, or output the values so that they can be consumed via interpolation. And so I published this under my own personal namespace on the Terraform registry. So that's Redu, R-E-D-E-U-X. And it's, I believe it's just called Terraform Kubernetes kubeconfig. And you can pull it down. You can source it in your own module, or you can use it sort of discreetly if you're just using a root module, and it will output a kubeconfig for you in your working directory. So it's pretty cool. And then you can, of course, consume that with the Kubernetes or Kubernetes Alpha provider, or kubectl directly, right? Whatever mechanism that you're using to connect to Kubernetes, right? It's going to produce that valid kubeconfig for you.
And every time you run Terraform apply, that file will be updated as well.
That's right. That's right.
That is my favorite way of generating files. Terraform as a template file renderer is such an underappreciated thing, but I'm kind of hoping, like 2021 might not be the year of the Linux desktop, but it might definitely be the year of Terraform as a template file provider.
Yeah, I totally agree, Kerim. By the way, this was like my first real exploration into the templating capabilities of Terraform. Like, I was aware of them, but I had never really tried to create something useful with it. And I was quite happily surprised with the templating functionality that exists in Terraform, especially natively. Like, everything I did didn't even require a provider. I had to use a provider to write the file, but all the templating stuff was just native Terraform, which is pretty cool.
It is absolutely amazing. We've been stress testing the template file function. I'm just going to call it that way, for generating Nomad, console, and vault configs just from Terraform, for the same reason that I asked Alex if I could use other Terraform functions to put data in, because when you bring all those parts together, that's when your IAC really starts living. Using a tool like Terraform to do hard-coded stuff, sure, it works, and it's definitely going to be better than clicking in a UI, but that's not where the full power lies. And once you figure out, hey, wait, so these certificates, I could actually, pop them in via Cloud Init, but generate them through Vault first and then push them in. Boy, it gets nice. It's definitely a nice approach.
Yeah, definitely. It's actually getting very, very close to having feature parity with what Helm is able to do, right? So once you have these manifests described in HCL, you can actually leverage all of the mechanisms in Terraform for doing iterations over collections, for doing conditionals. And so pairing that with the Kubernetes resources described in HCL for the Alpha provider, you can actually do all sorts of interesting setups that historically have only been possible with the likes of Helm or Customize, for example.
I think that chaining is just super powerful. Phil, are you able to give us a quick demo of the kubeconfig module?
I am not. Sorry, I'm not prepared to give a demo of it, but I'm happy to show it on the registry and talk about it. So let me share that real quick, if you don't mind, Kerim.
Absolutely.
I probably could be ready to give a demo.
Sorry.
Yeah. Sorry. Go ahead.
I was going to say, in the meantime, we've already shared a link for the module in the chat. Just if you're watching along, then you can definitely grab it from there, or just take a screenshot of Phil's URL bar.
Can you see my screen? Okay. Okay. Sorry, I never got confirmation there, Kerim. Can you see my screen okay or no? Okay.
Sorry.
So apologies. I probably could be ready to demo this in another 5 minutes if we keep talking, but that's a miss on my part. But here's the config, right? Here's a basic example of how you use it, right? And so the interesting thing about kubeconfigs, and this was a journey of exploration and learning for me as well, is that a kubeconfig really consists of 3 main parts, which is clusters, context, and users. And cluster describes your cluster endpoint. User describes your authorization and authentication against that cluster endpoint. And context is basically how you put them together. And it potentially includes a namespace for the context as well. And so you can have, within one single kube config, you could have one cluster, one user, and one context, or you could have many clusters and users and contexts and allow you to switch back and forth. And so this module allows you to adopt either pattern, whatever works for you. So if you're spinning up many clusters and you want a single kube config, you can do that. If you're spinning up a single cluster and you want a single kube config, you can do that as well. And so really you would use the output of whatever is generating the Kubernetes cluster for you. So whether that's EKS resource, the AKS resource, the GKE resource, the kind resource, right? Any of these, really, any of the many ways you can create a Kubernetes cluster, right? You can use this to generate from the output of that a valid kube config, and then put it in your working directory. But I want to show off something here, and this is new in Terraform. And so this is the ability to create these optional attributes of an object in a variable. And this is really what enabled me to be able to do this, and why it actually only works with Terraform 15 and above. So this is another reason to upgrade to Terraform 15 if you're not there yet. This is really cool and really powerful because I can also set default attributes for these. So they're optionals, and I can create a default if necessary. And so I can really, describe an object that is, quite complicated. And Terraform is based on Go, and Go is very type sensitive. So the ability to, add or remove attributes sort of ad hoc is pretty powerful in this. And this allows me to create, the many cluster kube config or the single cluster kube config without having to produce different modules. And so while I think the kube config is super valuable, I really wanted to show off this pattern because I think it enables a lot of other use cases that I want people to be aware of.
I think optional is just so amazing, and I'm glad it's finally in there because you literally mentioned all the reasons that I would give as well. It's nice to be able to fully type out the object, but say, you know what, this part might not be in there, so it's optional. It still allows for strong typing. It makes your module stronger, which means anytime you build a strong module, everything that feeds from that module is going to be as strong. And I think, when you put down a solid base, then you can build amazing stuff on it.
Absolutely.
So definitely a good reason to go to 0.15.
Do you mind if I actually switch back to Helm diffs? I do have a demo queued up for that, and I would really like to show that off.
Oh, I would love that. I mean, today is all about demos.
Awesome. So let me tempt the demo gods myself. I'm going to stop sharing just to pull up my my stuff without potentially embarrassing myself. And here we go. I can start sharing again. Okay. So I assume you can see my screen again because I just did the same thing I did before. But let me know if it's otherwise.
If you can make the font in the terminal a little bit bigger, I think that would be awesome.
All right, let me try to do that here. How does that look?
Slightly bigger.
Slightly bigger. Make it even bigger. How does that look?
Oh, that's beautiful.
Okay. Cool. All right, so what I've got here is just a basic Terraform config. You can see it right here. I've got the whole directory open in VS Code. So I'm using the Helm provider. I'm using version 2.1.0 because that is where we released Helm diff. I've got it set up, mostly as the standard configuration that you would expect, except for this is the new thing that you really need to pay attention to. So we've put this under a feature flag, and the feature flag for now is called experiments. And so as you may have caught on by now, right, we're very cautious about delivering functionality that we haven't validated and saying, please go use this in production. And so for that reason, right, we have put this under a feature flag called experiments. In the future, after we've gotten some, great validation, after, people like you, hopefully, if you have noticed issues, you've come open them on our repo so that we can fix them. We will graduate either this to another feature flag, perhaps called features, or we'll just make it a native part of the Helm provider. And that is really dependent on your feedback, as with pretty much everything that we do. And so we really value that feedback, and I appreciate it when you come and deliver it to us. Other than that, setting up that feature flag, everything else is really the same, right? You still have your Helm release resource. In this case, I have given it not a name, the default name. And I went to Artifact Hub. I grabbed the Prometheus repository, chart repository. I grabbed one of the versions. I'm telling it to create the namespace Prometheus and install it there. And that's pretty much the extent of it. And so what I've got here is a vanilla kind deployment, as I like to do. Kind is so easy. And you can see that by, I can run kubectl get namespaces or get n. I can forget the s and see what it does. Yeah, I didn't think so. All right, so you can see we've got nothing here. So no tricks up my sleeve like Alex was doing. I'm gonna go ahead and I don't think I have, wow, this is hard for me to read. No, it just looks like the one file is in here. Okay, so we'll go ahead and run a Terraform init. I have Terraform alias to TF because I like to type less. So I initted it, and I'm just bad at typing, let's be real. So now I'm going to run I'm going to skip the plan stage on this initial one, and I'm going to run a Terraform YOLO, as somebody called it recently, which I really like, which is just a Terraform apply -- auto approve, right? So don't do this in production, but do this when you're testing. This is a great way to test locally because it short circuits a lot of things. Please don't do this in production, right? Terraform plan is there for a great reason. As an infrastructure as code operator, you want to know beforehand what you're going to change, and Terraform plan is how Terraform tells you that. But in this case, I'm just going to go ahead and apply what we've got. You can see here, and I'm going to attempt the demo gods as well and just say Terraform YOLO. You can do it. You got it. So you can see it's creating the Helm release. This is actually going to take a few seconds, right? Prometheus is not, it's not the biggest app in the world, but it's not the smallest either. And so it's going to take a little bit of time to get it for the deployments to come up and all those things. And so I think it'll probably take less than a minute though. So after I do this, what I'm going to do is I'm going to pretend, again, I went to Artifact Hub. Some time has passed. I've been running Prometheus. Things have been great. And I'm going to do a chart upgrade. One of the things, the reason that I didn't do the plan to begin with is because on the initial create, we don't do a diff on nothing because that's not super valuable, right? It's just going to show you the entire rendered manifest. And if you're super interested in that, right, you can, and I encourage you, by the way, any Helm chart you are going to install, you should understand beforehand what it's going to install sort of from the base. It's really during this upgrade path that you want to understand what's changing. And that's where the value of Helm diffs comes in. And so what's going to happen here is I've got everything, so I can get, a kubectl, get namespace Prometheus. Whoops, I want to do get all in the namespace Prometheus, right? You can see I've got everything's up. Kind of hard to see with the big font, but you can see lots of stuff here, and you're gonna have to trust me that you can see actually most of that is ready, and it's all ready actually. So we're good. Prometheus is running. The Helm chart is installed. Okay. All right, so it's been a couple months. I have to stay, per my company's policy, N-1 on my Helm charts. And so I need to upgrade this thing. I can't just let it run forever. And so I saw that, N-1 right now is 13.8, I believe. So I went into my Terraform code. If you missed that, right, I just updated the chart version to 13.8.0. And this time I'm going to come over here and I'm going to do a Terraform plan. And it's going to refresh the state, and then it's going to show me all the changes that are happening that Helm is going to apply. And you could see, I'm scrolling through this kind of quick, but you can see in this instance, most of the changes are metadata updates that revolve around how Helm sort of manages the state of its deployments. I don't know that there's anything consequential in this one, so it looks like perhaps it was an update to the chart itself rather than to the Prometheus, application, which is, from my perspective. Oh no, here we go. So we actually have some. I'm going to pull this out a little bit. Great. So
and for the folks that haven't seen Terraform diffs, the yellow tilde indicates that this is an updated resource. If we had something that was completely new, it would be a green plus and otherwise a red minus.
Here we go. So here we have quite a bit of change in one of our chart managed resources. We can see that this is actually the Prometheus server, right? So it's a change on the Prometheus server. We've got these metadata changes, which we don't really care about too much, but we can see actually in the spec, in the container, there's actually a new configuration. And it looks like the Quay image has changed, or the image for Prometheus coming from Quay has changed from 2.24 to 2.26. So there is a real change happening in this Helm chart to the Prometheus application, and we're able to see it through Terraform using Helm diffs. And so I can go look, I can make sure that that version of Prometheus is good for what I'm doing. In this case, I'm gonna go ahead and assume it is for demo purposes. But if I was in ops at a company, as I have been in the past, I probably wouldn't be so quick to do that. I would go validate that that's gonna work for me in advance. So now we've seen that. We've seen mostly metadata updates. We've seen actually a Prometheus update to the app. And so now I can do Terraform apply YOLO, and we will once again, it'll just go ahead and I'll go ahead and roll that update out for us. If I had done Terraform apply without the YOLO, we would have seen the diff again, and then I could have said typed in yes before this. But for demo purposes, I like to do it this way.
I'm 100% on board with that. For demos and for local module development, anytime I do stuff, I just skip the plan, I do the auto approve, because it makes the whole cycle so much easier, and you get instant feedback. If you're building a module, you're going to be adding a handful of resources, inputs, outputs. Yeah, it's important to be quick. But as you said, don't do this in production unless it's Friday, 5 p.m. and you're about to sign off.
Oh, that reminds me, Kerim, of this time that Friday, 5 p.m., someone, I was working and someone made a change on our core router and brought down the entire network and said, I can't reach my servers anymore. Oh, well, time to go home. Yeah, don't be like that. Don't be like that.
Did the person have to come back on Monday, or was it okay?
No, the reason I'm salty about that, Kerim, is because I was left to fix the mess, right? And so that's the way it works sometimes. And so that's why you should be kind to both yourself and your coworkers, right? And it's not just about not following proper process, but if you accidentally make a change, and accidents do happen, but if you accidentally make a change and bring down a system and then leave, right, and people can't reach you, somebody else has to clean up that mess. And so Terraform really prevents you from getting into a lot of those situations.
It absolutely does, and to me, it's one of the biggest things I love about Terraform is just being able to, not just for modules, but just for infrastructure in general. For example, for our Azure account, we have an account repo. So anytime I build a demo, it's going to be there, and it's not going to be there exactly when I don't expect it to not be there. But because everything is codified, it only takes a couple more minutes to get everything back. Way better than wasting resources, way more sustainable. And it teaches me to make sure all my stuff is actually codified. Or, have the joy of going through a visual UI and figuring things out there. Like, what did I click again? How did I set up this cluster? Definitely not that. That was a beautiful demo. In the meantime, if you're watching along and you have more questions, definitely drop them in. TF YOLO is definitely a time saver. And if you assign Terraform to TF, you can probably save about 75–80% of typing, not across your whole typing, of course, but you know, it's these stats are definitely made up, and math was not my strongest subject, as you might have just discovered, but it's worth it. On that note, I do actually assign a lot of aliases to make things slightly more, you know, useful. So I would always have refresh in there, which is nice because once you update to Terraform 0.15, refresh and validate options are now part of Terraform. And for modules, I think, was it the get and init stuff is a lot more sensible right now than it used to be. As Terraform gets stronger, your infrastructure gets stronger. So that's a good reason to keep updating. Also, whenever your delta to the latest version is bigger than it should be, your update story is going to take a little while longer. But yeah, so we talked about the alpha provider, the beta provider, well, a potential beta release, figuring out names for providers. Are you soliciting community feedback for that?
We are definitely enthusiastic about hearing name suggestions, because we've been having the conversation for quite a while and we still don't have a good solution for it. It's hard.
It is definitely hard. I mean, there's only, it's one of the two hard things in IT, right? Like cache invalidation, naming things, and off by one errors.
And DNS.
Yeah, DNS, yes. Ooh, I can see Phil felt a little bit of pain there as you said that.
Absolutely, and IPv6.
Yeah, no, yeah, I hear you on that. So we demoed ArgoCD. I have to ask Phil, Flux CD, what's happening with that?
Yeah, so you know, Flux, really cool CNCF project that you know, takes the GitOps model for your Kubernetes manifests and will do sort of constant reconciliation for your apps, which is really powerful. You know, other projects do the same thing, like Argo. Flux, I would say, is a little bit more scoped, slimly scoped in its mission. And I'm excited about really two developments in the Flux space, which is one, the Flux team themselves have come up with a Flux provider, which is really cool. You can find that on the registry under the Flux CD namespace and download it and use it. There's a great example on the registry on how to get it to run and hook it up with GitHub. And you know, it's really powerful, and it's a really powerful way to continue to leverage Terraform within, you know, your workflow, even if your workflow doesn't involve using Terraform to deploy your apps directly. And so you still get all the great infrastructure as code goodness for your setup. And then you let Flux, which is a purpose-built tool for deploying your apps into Kubernetes, take over. And that's great. The other thing is, with the Kubernetes Alpha provider, we really are sort of changing the way that you can go about these things if you want, right? And so when it's matured, I have another module that I've created, which will install Flux for you using only the Kubernetes Alpha provider. And so, you know, basically, yeah, I was able to generate, like Alex showed, from the YAML manifests that create Flux from FluxCuttle, and generate a Terraform module with that essentially acts as an analog for, you know, the Flux install portion of FluxCuttle, right? It's not full coverage of FluxCuttle. It's not intended to be full coverage of FluxCuttle, right? But for that install part, you know, you can do that all just using the Kubernetes Alpha provider, which I think is really cool and really powerful. And frankly, you know, if you're looking at creating a provider that all it does is interact with Kubernetes to install custom resources and custom resource definitions, I would encourage you to look at the Alpha provider as potentially an alternate path to not having to maintain an actual application, a Go application, right? Which that if that fits in your wheelhouse, that's great. But if that's something that you have to stretch to do, I think we have a great alternative out there now. And so you can do whatever works best for you and your team.
I think that's a great call out. It's, there's this joy as an engineer of building something and solving the not invented here problem and going like, hey, we built this in the best possible way. But if you can take something that accelerates your work, that's tried and tested and has been around for more than half a decade and still works, which is an important thing. Yeah, there's a fair point in saying, you should be using that instead of maintaining your own. Figure out what provides value for your company in the best possible way or for your project and do that.
Yes, and I want to add that may be like create a provider, right? It really is what is best for you and your situation and your team. And we're not necessarily opinionated about that. Terraform has over 1,000 providers on the registry today, so huge provider ecosystem, and we love our providers and we love our provider maintainers, and thank you to all of them, right? All we're saying is, there is, for this one use case, an alternate approach that you can now consider if that's something that works for you.
I think that's actually a super good shout out. We literally just hit the 1,000 providers 2 or 3 days ago, and it is just mind blowing when you think about how Terraform evolved, how it started out with essentially being for AWS resources, and now whatever it is you want to do, I think you tweeted this at one point, there's a provider for that, and to me that is just so beautiful. Being able to bring all my configs together and deploy in multiple clouds on multiple kube clusters in multiple regions around the world, have it properly monitored and not have to copy and paste a value anywhere and just have it dynamically referenced, to me is my favorite way of doing infrastructure.
And we can always use more providers, and we really double down on that. We have a lot of projects and initiatives in flight to improve the developer experience for building providers. So there's a new SDK being designed and built that will offer all of the flexibility that you've seen with the Alpha provider in a much more developer-friendly way. The Alpha provider is a very early attempt at it, and the code base isn't the most accessible for maintainers, but we are building a brand new SDK that will enable users to use all of the new dynamic features that Terraform now has in the same familiar developer-friendly APIs that they're used to. There's improvements to logging from the providers coming. We're going to have structured logging available both for Terraform and the providers. There is already a mechanism in place where you can launch the provider standalone and attach a debugger to it. And you can greatly speed up the debugging cycle by attaching a Go debugger to your live running provider and seeing what's going on in there. So that's a huge improvement in developer quality of life, to be honest, in my opinion.
100% agree. I think we even talked about this specific part, the debuggers, during the Terraform 015 office hours, I feel like 2 weeks ago. It was a ton of fun. And if this is the kind of thing that you find interesting, audience member, because I know Phil and Alex do, we'll be hosting HashiTalks Build on July 22nd. Essentially a day geared towards people who build for our tools, not just with our tools. So if you're building a Vault plugin or a Terraform provider or anything in between, then this is definitely the day for you. Make sure to keep checking our Twitter and YouTube for this, because yeah, we'll have some good content for you. Also, think, Alex, you'll be talking about how the CRDs were implemented. I'm sure I can rope Phil into something.
Yeah, I'm really looking forward to that. We've actually had to take some really, let's say, creative approaches to provider development in order for the alpha provider to be able to dynamically react to new resources being available on the cluster. And so the whole schema mechanism internally is dynamic. It actually uses the open API definitions on the cluster to generate the types on demand at runtime. So there's a lot of goodies to be explored in there. And we're going to be talking about that during HashiCorp talks.
I'm excited for it. With that, we're already at the end of our office hours for today, but for tomorrow, my colleague Eric Feld will host Ashwin Venkatesh and David Yu for a session on console service mesh on Kubernetes. We'll have a link for that in the chat, but we'll also be on the community Slack, the CNCF Slack. So you'll definitely know about this. And if you're already thinking about what to do after KubeCon, because we all kind of enjoy hanging out together, HashiConf EU is happening June 8th through 11th, and we've got tons of great sessions for you. So head on over to hashiconf.com and register. And with that, any closing words from you two?
Just thank you to all of our users. I appreciate, how open you are with your feedback on how you use our products, specifically the Kubernetes and Helm providers. Please continue that. We love to hear from you. We value your thoughts and opinions on what's working and what's not working. Head on over to our GitHub repo and let us know if something isn't working like you expected or you would like to see a new feature. We really want to hear that.
Yeah, definitely. I fully second what Phil just said. We really want to hear from the community. We want to hear that you're using the providers, especially for the alpha provider, in order for us to be confident to take away the alpha label off of it. We need community feedback. We need you to come to GitHub and raise any potential problems that you had, describe them so we can look into them, so we can consolidate this into a mature provider.
I think that's a really good call out. We like to say that we want feedback, but we actually want the feedback. There's no guarantee that we'll be able to address every little bit of feedback, but it does help us. Even if nobody gets back to you personally, we still read it. And I think that's the most important part. It does shape our product directions. It does shape what we do. And you might have a use case that you think, hey, this happens to me all the time. And that might be because you have a super special use case that we have no idea about. So feel free to share it with as much detail as you can, with as much code as you can. And we'll figure it out together. With that, I think, yeah. Thank you. Good night, good evening, good day, goodbye, all of it, whichever time zone you are. Thank you for joining us today. Hope to see you back tomorrow, and have a good rest of your day.
Thank you, everyone.
Thanks, everyone.